Hello everyone, I am Singh, lecturer of computer engineering in Government Polytechnic College, Bundi, Rajasthan. Welcome back to our video lecture series on operating system principal subject. In previous videos, we have covered chapter 1, that is basics of operating system. In this video lecture, we are starting with chapter 2, that is your process management and scheduling. One more thing, if you like the videos or don't like the videos, please do provide us with feedback so that we can improve our content and quality of video in future videos. So let's start with chapter 2, and that is process management and CPU scheduling. So in this video lecture, we are covering process concept, and that is a wide topic, so it will take some time. So we are only covering process concept in this video lecture, and the rest of the topics will be covered in next video lectures. So let's start with the process concept. Now, what is a process? Normally, what we see in computer is a program. When we run a program, then it will become a process. Means a program that is under execution is called as process. A program that is under execution is called as process. कोई प्रोग्राम जब रन हो रहा है तो उसको हम बोलते हैं प्रोसेस. So when a program comes under execution, it always resides in main memory, or we can say in RAM. So while execution, process stays in main memory. So whenever a process starts its execution, it always wants CPU for its execution. So every process which is running will be assigned CPU for its computation. Okay. For example, when we write a program in C or C++ or in Java or in any other programming language, first we write that program, then we compile that program. In that process, means in those steps, this is a program. But once we run that binary code of that program, it will become process. Once it will become process, it will be running onto CPU and it will reside in main memory, or we can say RAM. So your process is an active entity. Active means it is running, while your program is a passive entity, means it is just staying in the system. So for graphical notation, we always use circle with process name. For example, P0, you can see on screen here that this is your process P0 and this is your circle. For graphical notation, we are using circle for the processes. Now, how and what does a process look like in the memory? You can see here on the screen that this is your memory area. Memory means random access memory or main memory. So here we have 5 parts of the memory. First one is a stack. So in a stack, it always contains temporary data. For example, function parameters, return address, and local variable. In heap area, we always use heap area for dynamic memory allocation. Means at runtime, if you want memory, the system will allocate memory from this heap area only. Okay. From data section, what we have in data section, we have global variables, so that whole program can use that global variable. Now we have text section. In this text section, we have process and other things like program counter. Right? So I think we have cleared with this memory area where your process will reside, means your process will reside in this text section. Now next thing is attribute or characteristic of a process. अब एक प्रोसेस के साथ में कौन कौन से एट्रीब्यूट एसोसिएटेड होते हैं वो हम देखेंगे. एंड इन दैट सीरीज फर्स्ट वन इज योर प्रोसेस आईडी. एवरी प्रोसेस हैज़ ए यूनिक आइडेंटिफायर कॉल्ड एज प्रोसेस आईडी. सो हर एक प्रोसेस के साथ में एक यूनिक आइडेंटिटी अटैच होती है, उसका नाम होता है प्रोसेस आईडी. फॉर एग्जांपल, अभी हमने पीछे 2 स्लाइड में देखा था कि जो आपका प्रोसेस P0 है, उसमें P0 क्या है, आपका प्रोसेस आईडी है. ओके, सो P0 इज योर प्रोसेस आईडी. Now next one is your process state. So while execution and when the process has been created, it has some state. For example, when the process is created or process is being under creation, its state is a new state. Means program is your process is under new state. When the process is ready for the execution, then it is your in ready state. When the process is running onto CPU, it is in running state. So likewise, we have many states for a particular process. Okay. Next one is your program counter. Now your process or program is a collection of instructions and data, and your instruction data have some address. So while execution, the next instruction that is to be executed, it has some address, and that address is stored in your program counter. So जो भी नेक्स्ट इंस्ट्रक्शन एग्जीक्यूट होने वाला है, तो उसका जो आपका एड्रेस होगा वो एक प्रोग्राम काउंटर में स्टोर होता है, जिससे आपका सिस्टम क्या होगा, उस एड्रेस को रीड करके और उन इंस्ट्रक्शंस एंड डेटा को एग्जीक्यूट कर सकेगा, राइट. नेक्स्ट वन इज योर सीपीयू शेड्यूलिंग इंफॉर्मेशन. सो किस टाइप की शेड्यूलिंग अप्लाई की हुई है प्रोसेस को सिलेक्ट करने के लिए, ये इंफॉर्मेशन आपका शेड्यूलिंग इंफॉर्मेशन में स्टोर होती है. देन वी हैव आईओ स्टेटस इंफॉर्मेशन, लाइक what type of input output device are needed for the execution of the process, that is stored in IO status information. Then we have list of general purpose register that is to be required for process execution. So in right side you can see a block where we have all the attributes of the process. Now this block is called as process control block. Okay, in short PCB. Every process has its own process control block, and this PCB resides in main memory. So while execution, this PCB gets updated every time as its value gets changed. For example, process state attribute updated as the state gets changed. Okay. List of open files gets updated as the files required by the process gets changed, right. Protection information gets updated, right. One thing remains same always, that is your process ID. Okay. So this all attributes, we also call them as context of a process, right. So we have to remember those some important terms while studying this chapter, and that is your PCB and context of process, attribute of process, because we will be using it later when we will be discussing your process state diagram. Now as we have discussed, a process as an attribute, it's process state. Now we have many states of a process. Okay, in that first one is new state. So here you can see a process state diagram. Now every process will go through these states. In that first one is new state. So what is a new state? When a process is created or it is being under creation, the process state value is new. So जो आपका जब process create हो रहा है या create होने वाला है, उस टाइम पे जो process state variable है और attribute है, उसका जो value होगा वो क्या होगा, आपका new होगा. Then once this process is ready for the execution, then the process will move to ready state. So at new state we have many number of processes, because many number of processes can be created at a time. While in new ready state we can have many number of processes, because many number of processes can be ready for execution. Okay. Next is your run state or running state. In this state we have only one process at a time, because in uniprocessor system we can assign CPU to only one process okay. But we have discussed in ready state we can have n number of process. Then how this one process can get selected from ready state to be placed in running state, or how a process can be allotted CPU, that is based on your scheduling algorithms. Okay, so with the help of scheduling algorithms we can select a one process, and then it will be selected, and by the help of dispatcher that process will be loaded into CPU. Then we have wait state, or we can say block state. In this state, when a process will come in wait or block state, whenever a process required input output devices for its execution, it will placed to wait or block state. Okay, whenever a IO request will be made by a process, that process will be placed into wait or block state. So after using those IO devices, that process will again go back to a ready state, and again the scheduling algorithm will select that process, and again your CPU will be allotted to that particular process. Okay. Now we have two other states: suspend ready state and suspend wait state. In case of suspend ready state, what is the scenario? For example, in ready state we have n number of processes, and the process keeps coming and it is being created time to time. So the RAM can get exhausted. Means आपकी RAM की जो साइज है वो उस जिस टाइम पे वो प्रोसेसेस क्रिएट हो रहे हैं, सो उसके अकॉर्डिंग वो फुल भी हो सकती है. ठीक है. इफ योर RAM गेट्स फुल, then in that case the new process will be shifted to suspend ready state. Okay, and that is your backing store, or we can say it, and this storage is in your secondary memory. So once we have space available in main memory, then again from suspend ready state, or we can say backing store, we can resume those processes and will get back to ready state. Same happens with your suspend wait state. For example, we have many processes, those are waiting for IO completion or IO execution. In that case also, if memory gets full or main memory gets full here, in that case also some of the process will get suspended and placed to the backing store, or we can say in secondary memory. Once the space is available in main memory, then again those processes will be resumed and placed back to your wait and block state. Okay, wait or block state. So after successful completion of a particular process, that process will be terminated, and the value of process state attribute will be terminated. Okay, so this is all about process management and process states. If you have any query, you can shoot it in your comment section. I will try to answer every query in every possible way. Thank you so much. And next videos we will be covering rest of the topic from chapter 2.